Hello friends, welcome to C# Intermediate to Advanced tutorial. Now you are watching a final part of the subseries Interprocess Communication via Mutex. In this video, we will create two processes and see how Mutex Lock and Release is working. First, we learned about the Mutex. Then we talked about the example which we are going to create. So here process 1 is a console application and threading, collection, IO, all these namespace we are including. I'm not sure we are using collection. We will see when we go through the code. So in the main entry, if you see, process 1 is creating the new mutex object. When we are creating the mutex, we pass false. That means we are not owning the mutex. That means the other process, when we start a process 2, that can also own this mutex, or that can also access this mutex. And we are giving name as read write for this mutex. So this name will be useful for process 2 to grab this same mutex. So we are storing this mutex as a GL mute. Then we are running a outer loop, and this loop runs for 10 times. So GL mute dot WaitOne. That means here in the WaitOne, it performs two tasks. One is tries to occur the lock, and if the lock is already occurred, then the process will wait here. That means the process will get blocked on this call. So if it was not occurred by any process, then the current thread or the current process will get inside. So even though if it waits, the other process, when it releases, then it will get a chance to occur the lock and the process will enter inside. So here we check whether this is the very first time we are entering the piece of code. So I equal to 1, that means the very first loop. That time we state now start other process. So here we print the statement stating now start other process, and we put a wait of 10 seconds here. So this 10 seconds is sufficient enough to navigate through the file system and run the process2.exe. So when we are demoing it, that time we will be make necessary arrangement so that we can start process P2 within 10 seconds. Anyhow, process P1 will give a 10 second time. So if you feel it is challenging, then you can increase this initial wait to 20 seconds. Next, after printing this message, the process 1. So the process 1 will, it's a writer process. It opens a stream writer for the file at the drive temp location. File name is test. And once again, it runs one more inner loop. It runs for 10 times. Then we will be printing a sequence number. For the first time, the numbers will be 1, 2, 3 like that. For the second time, it will be 2, 4, 6, 3, 6, 9. So it will continue up to 10, 20, 30 like that. Right, I into j. All right, next. After appending this string with this sequence, we are stating writing line of text I stands for this loop, outer loop counter, writing line of text 1, writing line of text 2, likewise you will see. Then we write the sequence. So this is the sequence string write using SW stream writer dot write line method, and we write the content to the text file. So text file is a common resource, right? It can be shared among multiple processes, P1, P2. How many processes you will create, all process will have access to this file. So after writing the line, the process 1 closes the file handle, then it goes for a 2-second sleep. So this 2-second sleep is for the demo to go smooth. That means you can clearly see that process 1 is writing, process 2 is reading. So since there is a 2-second delay, you can see the demo in a nice way. But in real world, this kind of sleeps should be avoided. Alright, after writing the line of text, process 1 releases the mutex. Here if you see GL mute, before writing anything, the process 1 makes a call to WaitOne, so it will occur the lock. If not possible, it will wait, and once it occurs the lock, it performs this task. Then finally process 1 releases the mutex. So by this time, if a reader is waiting on the WaitOne, after this writer makes a call to this release mutex, reader will enter inside. So that we will see in the next slide. So here is the process P2, threading, IO, correction we are not using. So the important thing here is we are using open existing, and we reference the mutex name. So the name is registered with the OS, right? So other process P2 can claim the same mutex, and here it has GL mute. So this kernel object global mutex is same between P1 and P2. So P1, P2 access the mutex maintained by the OS. So they both now having the same mutex instance. Now our process P2 runs, our process 2 runs for 10 times. So here we are making call to WaitOne. If writer is using the mutex, here we will get locked. We in the sense of process 2 will get locked. Once writers are finished with the task, it will release the mutex, and the process P2 can get inside. So that means it will occur the lock. Once it occurs the lock, it opens the stream reader, and if you see the shared resource, same resource we are using. So this is the file we are using when we are writing the object. The same file now we are reading it. The method we make call is a read line, and we have the sequence line here. And finally we are printing that sequence line in the console window. Then we go for a 2-second sleep. And once the read operation is completed, we make a call to release mutex. So that's all here. Now we will go ahead and create these 2 sample applications. Now it's demo time. So first we will create a console application. So console application.NET framework. Here we will choose a directory, D drive temp2, and we will name this as process 1. So as the code was already explained, here we will include the required namespaces. Then we will add the code inside the main. So this will be our process 1. We will rebuild the solution. Now we will create a second process. So console application. We will pick same folder, and this time we will use it as a process 2. So this will be the reader process. So in process 2 we are creating the same piece of information. We are including the threading namespace, collection not required, and IO we need it. Then inside the main function, the code was already explained, so we created the second process as well. Now we will build both these solution. This one is already built. There is a build error, so just missed a closing parenthesis. Now we will build the second process. So since we have only 10 seconds time, so moving to the drive, that's a process 1, right? We will just keep it ready. I'm not hitting enter here. Let me open one more command prompt. So let's copy this path. Paste it. Process 2. Now once I hit enter, we have 10 seconds to start the second process, and we will window it so that we can see both the process 1 and this is process 2. So this will print more line, right? So this will print a fixed line of text stating line 1 is ready, line 2 is ready, likewise it will go. Alright, now let me hit enter on this window and you will see a "10 seconds delay." Now I'm hitting enter here as well. After 10 seconds, you will see writing line of text 1 and it read that. Second line is read, third line is written. And if you see, there are two different processes and they both are accessing the shared resource. I mean the flat file. So Mutex is somewhat dangerous to use. So what you have to do is you have to handle the exceptions properly. So after locking the resource, if there is a exception and if a Mutex is not released, and if there are multiple processes which is accessing the Mutex, all will get locked. So that's all here in this video. Thank you for watching. Bye.